So up till now, we were able to solve all the questions by considering a single point as a pivot. And the only thing was that we were required to consider a point as a pivot smartly. So this is what we'll be doing for this one. We'll calculate the moment of force about each pivot, and the other end is considered as a force. When a point is taken as a pivot, the force passing through the line of action or through the axis of rotation cannot produce the moment, as perpendicular distance from the pivot becomes zero. So just note it down, explain what do we exactly mean by this. ठीक है, जो फॉलो अप एग्जाम्पल है उस पर ये वाली आपकी पूरी प्रॉपर्टीज एज इट इज़ यूज होंगी, एंड देन इट वुड बिकम क्लियर कि व्हाट डू वी मीन बाय दिस डिस्क्रिप्शन. So here we have the example, a very important one. If you're able to understand this example, it means you'll be able to solve the double pivot problems. So the question reads, a uniform rod AB of weight 100 newtons and length 2 meters is supported by two vertical strings at the end, and its end and carries a load of 20 kilograms as shown in the diagram below. Determine the tension in the string. So we need to find the value of tensions in the string. I can call the tension on the left side of the string as T1, and we can call the tension on the right side of the string as T2. And these two values would not be equal. First of all, if there were no load of 20 kilograms, this one, then these two values of tension would be equal, would have been equal. But in this case, since you have some extra mass on the left side of this rod, uniform rod, hence the value of T1 would be more compared to the value of T2. But in any way, the value of T1 and T2, these two values would be different. So now the thing is, we need to apply the principle of moment, the same one, and we have to select a certain pivot for it. So what you can do is let's call this one as point A, as written over here, and the other one we can call the point B. So what I'm going to do is I'm going to consider the point A as a pivot. Okay, this is the first step. I'm going to consider one end of the uniform rod as a pivot, and what I write here is considering point A as a pivot. Okay, considering point A as a pivot. So A is your pivot. So we have the point A as the pivot. Now you need to apply the principle of moment about the point A. ठीक है, इस पॉइंट के क्रॉस, इस पॉइंट के अबाउट आपने प्रिंसिपल ऑफ मोमेंट अप्लाई करना है. What is the principle of moment? The same one, that the sum of clockwise moment of force equals the sum of counterclockwise moment of force, then the object is in equilibrium. So what we do is check out the forces which would produce clockwise moment and the forces which would produce counterclockwise moment. But the most important thing is, once you have chosen the point A as a pivot, this force would not be producing any moment of force. Why? Because the line of force is passing through the axis of rotation. आपकी जो line of force है, it is passing exactly through the pivot, and the distance, the perpendicular distance of the force from the pivot is 0, and hence the moment of force would be 0. So once you have considered the point A as a pivot, T1 की वजह से कोई भी moment of force produce नहीं होगा. So the forces that would be producing the moment would be T2, which would rotate the block like this, anti-clockwise. T1, sorry, this force of 100 Newton, it will rotate the block, the rod, clockwise, and this mass of 20 kilograms, it would also rotate the block clockwise. And we can convert the mass into weight. that would be 196 Newton. Take a W equals to mg, the value of g is 9.81. Then you can hit it on the calculator. So let us apply the principle of moment. T1 तो equation में use ही नहीं होगा, ठीक है, forget about this. So what do we have is sum of clockwise moment. So this is your first force, 196 times the perpendicular distance of that force from the pivot, which is 0.5. So 196 times 0.5. Let me write it over here. Plus, because there's another force that would produce clockwise moment. That is the force of 100 Newton. Now, what is the perpendicular distance of that force from the pivot? It is 1 meter. Okay, this is the line of force and this is the axis of rotation. The distance between these two is 1 meter as given in the diagram. 100 times 1 and that would be equal to the sum of anti-clockwise moment. And there's only a single force that would produce the anti-clockwise moment, that is T2. So we don't know the value of T2, so we're going to write it as it is, T2 times the perpendicular distance of T2 from the pivot, and the perpendicular distance of T2 from the pivot is 2 meters. You can sort it out indirectly. 1 plus 1, that would be 2 meters. So from here, you can rearrange it to find the value of T2. You can hit it on the calculator, and the value of T2 that you'll be getting would be 100. Okay, just hit it on the calculator, you'll get the value of T2 after a simplification, and the value of T2 is 100 Newton. So now we know that one of the tension on the right string would be 100 Newton. But that's not the end of the question. We were asked to determine the tensions in the string, which means we need to find the value of T1 as well, which is the string on the left side. And we know just by looking at the diagram that the value of T1 would be greater than 100 because there's some additional mass hanging on the left side of the string. So we use the same method, but in this case what we're going to do is we're going to consider the point B as a pivot. You see, now we're considering another point as a pivot, so that's why we call it double pivot problem. Now think about it. Once you have considered the point B as a pivot, this force T2 would not be able to produce any moment of force. Why? Because this force is now passing through the pivot. So you forget about this one once you have considered the point B as a pivot. So you'll be getting one force, T1, and T1 is just like pushing the uniform rod upward, and it would rotate the rod clockwise. It would turn the rod clockwise. And this weight of 196 Newton, it would rotate the rotate the rod anti-clockwise. The force of 100 Newton would also rotate the rod anti-clockwise. So now let us apply the principle of moment considering B as a pivot. Let us add the clockwise moments on one side and the anti-clockwise moments on the other side. So what are the clockwise moments? It is T1, this force T1 times the perpendicular distance of this force from the pivot. So T1 times 2 meters. The value of the T1 would be written as it is. Okay. So once you have calculated the value of T2, now you're applying the principle of moment at B, considering the point B as a pivot. T1, the force T1 would rotate it clockwise. So you write T1 times 2. That would be the moment of force T1. And that equals to the moment produced by this force, 196 and the perpendicular distance was 1.5 plus the moment produced by this force, because that would also make it rotate anti-clockwise. So the moment produced by 100 Newton would be 100 times 1. Because the perpendicular distance of this force from the pivot is 1 meter. Now you sort it out in order to find the value of T1. The answer that you'll be getting would be 200 Newton. Exactly, you'll be getting 197 or 196 something. In 1SF, it would be rounded off to 200. So let me write down the exact answer first. So the thing is, once you have applied the principle of moment at point A, there's another method by which you can find the value of T1. And that method is by using the property, if the object is equilibrium, which the object is, because only then we were able to apply the principle of moment. What you can do is you can write down this thing, that the sum of forces in any direction would be 0. So if you have found the value of T2 already, what you can do is you can add the upward forces and put them equal to the downward forces. So what are the upward forces? T1 and T2. The upward forces are T1 and T2. So T1 plus T2, that should be equal to the downward forces, which is 196 plus 100. So 196 plus 100. But since in the first part of the question you already calculated the value of T2, so you write down the value of T2 from there, which is 100. So T1 plus 100 equals 196 plus 100, or you can write it as 296, and from there you get the value of T1. As you see, this 100 cancelled out, you're left with 196 newtons, and once again in 1SF you can write it as 200 Newton. So you are able to find the value of T1 by this method only if you consider one of the point as a pivot. And if you consider the point B as a pivot first, you'll be getting the value of T1, and then you can use the same method to get the value of T2. Okay, so this is the second question that we have, a very similar one. You use the same method. So what we're going to do is we're going to call this one as point A, like we did previously, and we're going to call this one as a point B. So left end of the rod as a point A and right end of the rod as a point B. And all the masses you can convert into forces. You can convert them into weight. So for example, this one, the weight due to the mass of 5 kilograms would be 5 times 9.81, W equals to mg. So the weight of this force would be, of this mass would be 49.1 Newton. So you have a force of 49.1 Newton. Okay, you can even write it as 49. So forget about the mass. We have the force. We'll be considering the force as 49.1, because what we need to find T1 and T2, these are also forces. These are not the masses. Then you have the mass of the rule itself, the mass of the rod itself. What is the mass of the rod? 100 kilograms. And since this is a uniform rod, the mass of the rod would be exactly at the middle point. The weight of the rod would be exactly through the middle point, through 50 centimeter mark. And let us convert this mass into weight as well. So 9.81 times 10, what you'll be getting would be 98.1 newtons. Okay, so now ignore the masses. Let's say these are not even there. We have converted the masses into forces. So how many forces do we have? T1, then this one, second force, third force, fourth force. We have 4 forces. 2 of them are given and 2 of them are to be found out. T1 and T2 are to be found out. So let us apply the principle of moment at point A. Alright, just like we did previously, let us apply the principle of moment at point A. So consider A as pivot. So if A is your pivot, there would be no moment of force produced by T1, because in that situation T1 is passing through the pivot. Perpendicular distance आपका 0 हो जाएगा and there would be no moment of force. So you forget about T1 once you have considered A as a pivot. So how many forces do you have? You have the force 98.1. You would rotate it clockwise. This one would rotate it clockwise, and T2 will rotate it anti-clockwise. So clockwise, sum of clockwise moment equals the sum of anti-clockwise moment. So 98.1, the first one force, times the perpendicular distance of that force from the pivot would be 50 centimeter, because the weight is exactly through the middle, plus the second force that would rotate it clockwise, 49.1, times the perpendicular distance of that force from the pivot. So you see, यहाँ से onward आपका end तक distance है 40. The total length of the rod is 100. So what would be the distance of this force from the pivot? Pivot आपका इस side पे है. So it would be 100 minus 40, and that would be 60 centimeters. So ये distance आपके पास आ गया 60 centimeters, equals, what is the force that is producing anti-clockwise moment? T2, only this one. And what is the distance of that force from the pivot? 100 centimeters. So T2 times 100. Okay, then you hit it on the calculator, do the simplification. The value of T2 that you'll be getting would be 78.5. And in 1 SF we can write it as 80 Newton. So this is the value of T2. Now once again, once you have the value of one of the forces, you can find the other one by either of the two methods. The one of them is consider the point B as a pivot, and the other one is the sum of vertical forces should be equal to the sum of upward forces should be equal to the sum of downward forces. But I'm going to consider the same method, which is consider the point B as a pivot. So we're going with the same method. Consider B as pivot. Consider the point B as pivot. So I'm going to raise the arrows, the clockwise and anti-clockwise arrows. So once you consider the point B as a pivot, so this is your pivot now. Around this pivot, there would be no moment of force produced by the force T2, because T2 is now passing through the pivot itself. There would be no perpendicular distance, hence no moment of force. So T2 is not producing any moment of force. T1 would rotate the block clockwise, this force would rotate it anti-clockwise, this would rotate it anti-clockwise about the point B. So let us write down the expression. So T1 times 100, the moment because of that force would be T1 times the perpendicular distance from till the pivot would be 100. So T1 times 100. T1 times 100. And that is the only force that would rotate the block clockwise. So that equals to 98.1 times, what is the perpendicular distance of that force from the pivot? It is 50 centimeters. Plus, what is this third force? 49.1. That would also rotate it anti-clockwise. So 49.1 times, what is the perpendicular distance of that force from the pivot? Is given over here, 40 centimeters. Okay, so you sort out this thing, you simplify it to find the value of T1, use the calculator for this part, and the T1 would come out to be 68.7 and to 1 SF we can round it off to 70 Newton. 70 Newton. And you see the value of T1 is actually the value of this tension on the left side is smaller than T2 because there was an additional mass of 5 kilograms placed close to T2, and hence the tension in the on the right side or on the string on the right side would be more compared to the string on the left side. So this is how we solve the double pivot problem. Once again, after you have found the value of T2 up till this step, you could have done the same method once again, that is the sum of vertical forces, the sum of upward forces equals the sum of downward forces.